Question 12a. Using completing the square method, solve correct to two decimal places the equation 3y squared minus 5y plus 2 equal to 0. The equation is quadratic. So we are going to outline the steps that are involved when using completing the square method. This is the equation you are solving. Step 1 is to make the coefficient of the term that is squared y unitary, that is 1. The coefficient is always 1. To achieve this, divide through by 3. Divide 3y squared by 3, you have y squared. You divide the second term by 3, you have minus 5 over 3y. You divide the constant term by 3, you have plus 2 over 3. You divide 0 by 3, it is 0. The next step is that you transfer the constant term to the right hand side. This is the constant term, the term without the variable. If you transfer it to the right hand side, it becomes negative. Next step is to add square of half of coefficient of y to both sides. So you get square of half of coefficient of y. Here, coefficient of y is minus 5 over 3. So you look for half, means 1 over 2 times minus 5 over 3 all square. No 10 can reduce. If you multiply, you have minus 5 over 6 all square. So you add this term to both sides of that expression. So the term has been added to both sides. The next step is to ignore the term that contains y. This term that contains y, you ignore it. And at the same time, you evaluate or simplify the right hand side to a single fraction. If you ignore this term, you have this result. So we have equal to minus 2 over 3 plus minus 5 squared is plus 25. 6 squared is 36. The LCM of 3 and 6 is 36. We are trying to simplify the right hand side. Divide 36 by 3, you have 12 times minus 2, you have minus 24. Divide 36 by 36, you have 1. 1 times plus 25, you have plus 25. And when you add, you have 1 over 36 to be the right hand side. Next step is to combine the squares in the left hand side. You combine y squared and this term. This step is like factory add power of 2. When you do that, you have y minus 5 over 6 all squared equal to 1 over 36. Next step is to take square root of both sides. So you have square root of the left hand side. In quadratic equation, you always have 2 roots. For us to achieve that, anytime you are taking the square root of the left hand or the right hand side, you always attach plus minus. Square root of 1 over 36. From here, square root will remove square. You are left with 5 minus, you are left with y minus 5 over 6 equal to plus minus. Square root of 1 is 1 and that of 36 is 6. Next step is to solve the resulting linear equation for y. You simply transfer this term to the right hand side and you have y equal to 5 over 6 plus minus 1 over 6. The plus minus term means you can write this expression twice, starting with minus before plus. So you have 5 over 6 minus 1 over 6, or 5 over 6 plus 1 over 6. You have like fractions. You subtract and you add. You have this expression, and you have 4 over 6 or 6 over 6. When you reduce and divide, you have 2 over 3 or 1 as the value of y. Question 12b. Given that m is equal to, bracket open, you have the entry in the first row 1, 2, 4, 3, the second row, matrix n with entries in the first row m, s, second row n, y, and the product of matrix m and n is equal to the matrix with the entries in the first row 2, 1, second row 3, 4. Find matrix n. From the problem, the product mn first is multiplying matrix m by matrix n, and the product is given to you as this matrix. So when multiplying, you use this first row to multiply first column. That is 1 times m is m, plus 2 times n, you have 2n. That is what you have here. If you are done with that, the same first row multiply second column. 1 times s is s, 2 times y, you have 2y, you add them together. You use the second row to multiply first column. That is 4 times m plus 3 times n in this form, and the same second row times second column, and that is 4 times s plus 3 times y in this manner. By equality of matrices, the first entry here is equal to the first entry here. That is m plus 2n equal to 2. You call that equation 1. Also, we have the second entry in the first column is equal to second entry in the first column the other side. That is m 4m plus 3n equal to 3. So you have 1 here equal to this entry, then 4 equal to this entry. You have 4 equations. Equations 1 and 2, they have variable m and n in common, so you solve 1 and 2, then 3 and 4 simultaneously at separate times. We start with equation 1 and 2. This is equation 1, this is equation 2. I want to eliminate variable m. To achieve that, this place needs to be 4. You don't just write 4 there, but you multiply through equation 1 by 4, and equation 2 remain the same. If you do that, you have 4m plus 8n equal to 8. Equation 2 remain the same. To eliminate m, since the sign are the same, opposite, that is plus plus, you subtract. If you subtract, here becomes 0. So you have 8n minus plus 3n, which means 8n minus 3n equal to 5n, and 8 minus 3 equal to 5. Divide through by 5, and you have n equal to 1. To get m from this solution, you substitute n equal to 1 into either equation 1 or 2. So we are taking equation 1. That equation is m plus 2n equal to 2. Where you see n, replace it with 1. So you have m plus 2 times 1 equal to 2. That is m equal to 2 minus 2, and you have 0. So you know you have to find matrix n now. So you know m and n. If you solve equation 3 and 4 simultaneously, you get s and y. Following similar procedures, if you solve equation 3 and 4 simultaneously, you have y equal to 0 and s equal to 1. So this is matrix n. M is 0, m is 0, s is 1, then n is 1, and s is 0. So matrix n is 2 by 2 identity or unit matrix. Pittacus simplified maths. If you are viewing and watching from YouTube, don't forget to subscribe. Also like and share PSM videos. If you are viewing and watching from Facebook, follow and like the page. Also share PSM videos.